Let us look at motion along a space curve. An example is this motion of asteroid 2020 SW, which was discovered on September 18 and flew close to the Earth, or passed close to the Earth, closer than even some satellites, on September 22 of this year, that is 2020. So I took the animation from NASA's website. Now we are down to a laptop monitor on Earth. Okay, and so here we are considering the motion. Okay, the radius vector at point P, say this is the origin, is connected here and it is moving along this curve. So you know this, that what happens is our velocity is dr over dt, and the direction of the velocity is that of the tangent at P, and in this case let's take the orientation as that this is the way the curve is moving as t is increasing. Alright, so we will do some calculations now. So let us look at this example, that a curve is traced by this radius vector, and we have to find the velocity vector, okay, the acceleration vector, okay, and we have to find the speed, okay, just like a textbook example. So for the velocity vector, what do? We compute the derivative of r at any point t, okay, and that is going to be, let's just calculate, okay, so we are just revising our calculus 1 also here, okay, so we are going, yeah, sorry for that disruption, I just wanted to enlarge the the recording area. Okay, so we are going to look at the derivative of this, and I think a good thing here would be, and again we are mostly reviewing our algebra here, okay, so we are differentiating, let me factor e to the 2 out, t out, you know, very derivative friendly quantity. So we got this, all right, so out, and that is factored out, right? So what we have then is this, that if we look at the derivative, this differentiates to what? Simply e to the t, this factor is left alone. All right, and remember this, one part is scalar here, the other is vector, but still our properties hold, okay, and now this is left unaffected, okay, and we will differentiate, oops, sorry, this portion here. So what we get here is the derivative of cosine is negative sine, and the derivative of sine is cosine, and that of t is 1. So what we got is, we got that the velocity vector is how much? Let's write them down. So we will add these components together, so we get cosine t minus sine t, and we get sine t plus cosine t, right? And here what do we get? Simply t plus 1, okay, so this is what we have for the velocity, all right, and then for the acceleration, okay, we will differentiate it again. Should not take too long, hopefully, okay, and again we want to review lots of things, algebra, trigonometry, everything with full force. So I'm not writing d over dt here because I'm going to write the derivative directly. So the derivative of e to the t is e to the t, and then for the next part, what shall we have? E to the t, and then we are differentiating this quantity, and I'll be changing it along as I go. So cosine t becomes negative sine t becomes what? Cosine t. Here sine t becomes cosine t, and then I have a typo here, I apologize, t and t here, okay, all right, and the derivative here is simply 1. So this is my acceleration vector, right? Okay, and then we have to get the speed, okay, and so the speed would be what? Simply the magnitude of the velocity, okay, and remember this, that is the velocity is directed towards the tangent vector, right? So meaning that the magnitude of this quantity, right, and this is going to be the square root of, right, just the components is squared and added, right? So when we square the components, what will happen? E to the 2t will factor out again, all right, and then what we shall get in the other bracket is, let me just change the bracket here, so we will get what? I could have taken a break and brought you the whole calculation afterwards, just kind of overusing this privilege by YouTube of giving me so much space on a non-monetized channel. So here we got this is squared, right, and then we got what? T plus 1 is square, right? T plus 1 square, okay. Oh, it went outside the recording screen, but don't worry, let's bring everything inside, okay, by doing this simply that right, very good. So notice this here, cosine t, this quantity will become what? I'm reviewing trigonometry here. We are doing multivariable calculus, but we are just doing it in two simpler ways. So we got this cosine square t, then we got, excuse me, then we got the sine square t, right? And then we have minus 2 sine t cosine t. That's what we get a result of, like foiling. And when we FOIL this, everything would be the same except what? Except that the product term will change to plus, and now life is so simpler, so much simpler. These guys cancel, and this part simply becomes what? Okay, this part simply becomes, okay, so this is taken care of by this, and then this is a 1, this is also a 1, so all the trig functions are gone, and we simply get a whole number here for this. So this becomes a 2, right? Okay, so what we have is we have this here, that this whole thing is a 2 simply. We factor e to the 2t out, and that will be positive, so it becomes a t, okay. And inside the square root, if you FOIL this, this will be t square, okay, plus 2t plus 1, and 1 added to that 2 will be 3. So this is going to be the speed, right? So magnitude of the velocity is speed, and remember this, the direction is the direction of that of the tangent vector, all right?